In this lesson, we will continue to practice problems where we are solving quadratic equations by factoring. This is the second part that extends the concept a bit more into problems that are a little bit more involved than the problems on the previous lesson. Recall that when we are asked to solve a quadratic equation, one way to do this is to use the zero factor theorem, which requires us to have zero on one side and then factors on the other. And then we can make smaller equations by setting each factor equal to zero and then solving for the variable. Couple of comments here. Before factoring, make sure you have zero on one side and a polynomial written in descending or ascending order on the other. And then I find it helpful to rewrite problems so that the first term of the polynomial is positive. And I'll talk about that as I encounter it on the examples. So in our first example here, solving using the zero factor theorem, we have a quadratic equation, x squared minus x equals 20, and we'd like to use the zero factor theorem. But the first thing we need, remember, in the zero factor theorem is to make sure that one side is equal to 0. So notice that I have x squared and minus x on one side and 20 on the other. The reason I'm going to move the 20 over to create a 0 on the right side is not because I want 0 on the right, but it's because x squared is a positive on the left side. So I'm telling myself, okay, I need to create a 0, so I'm going to move that 20 over to the other side. And it doesn't collect with anything because it's not a like term. So I end up with x squared minus x minus 20, and then I get 0 on the right. So on the right side, I have my 0, but remember that I need to create factors on the left. Notice that on the left side, I have a trinomial that starts with a 1. That means I can use my little factor pair shortcut to do the factorization. I don't see a number in the middle, but I know it's a -1. And when I do my factor pair, remember I'm going to say 1 times -20. That gives me -20, and I'm looking for the factor pair that adds to -1, which would be 4 and -5. 4 times -5 is -20, and 4 plus -5 is -1. So as I factor with my factor pair shortcut with x squared, I need x and x, and then for my factor pair plus 4 because of +4, and then -5 because of -5. Once I have 0 on one side and factors on the other, I can make smaller equations by setting each factor equal to 0. So x plus 4 equals 0 or x minus 5 equals 0. And then I'm going to finish solving by isolating x. So I'll subtract 4 to get x by itself. And in the other case, I will add 5 to get x by itself. And this gives me two solutions for my quadratic equation. In the next example, again, I have the issue, I have x squared, which is a quadratic, but I don't have my 0. So x squared is positive right now, so I'm going to move my 144. 144 is positive, so I will remove it by subtracting it off of both sides. And this is going to give me x squared minus 144 equals 0. Notice in this case that I end up with a difference of two squares, which is pretty straightforward in terms of factoring. What do you square to get x squared? X. What do you square to get 144? 12. Remember, we would have a minus and a plus in either order. Now this gives us two equations, x minus 12 equals 0 or x plus 12 equals 0. And then I'm going to isolate x in this case by adding 12 to both sides. This gives me x equals 12. Or I can subtract off 12 to get -12. In this third example, it's a bit more complicated. I notice that I have factors on the left, x minus 3 and x plus 18, because they're multiplying binomials. But what I don't have on the right side or the other side is a 0. In order to get that 0, I'm going to have to move that 12x over, but I can't move it until I have terms to combine with. The only way I can get terms on the left side there is to actually distribute to create the terms. So I'll have to do that in this case. X times x gives me x squared. X times 18 is 18x. Then -3 distributes through to give me -3x and then -54. And the other side is still 12x. Now I need to move that 12x over to gather with the other term. So I'm going to subtract it off and I'm going to collect it together with these terms right here that are x terms. So I'm going to clean this up a little bit. I've got x squared, 18x minus 3x minus 12x. 18x minus 3x is 15x, minus 12x gives me a positive 3x, and then minus 54, and then 0 on the right. So I do have my 0, and on the left side I have a trinomial that starts with a 1, so I can use my factor pair shortcut for this. So we're looking at two numbers, so we've got 1 times negative 54 is negative 54, and we're looking at two numbers who would multiply for that, and that's going to be 6 and negative 9. 6 times negative 9 is negative 54 if you add them together. Excuse me, negative 6, sorry about that, and positive 9, because I need it to be a positive 3 in the middle. Negative 6 plus 9 is 3. So this gives me x minus 6, x plus 9. Now I can create smaller equations for solving. X minus 6 is 0, or x plus 9 is 0. And then I can isolate x, in this case, by adding 6 to both sides. So that'll give me x equals 6. Or in this case, subtract 9 off both sides to get x equals negative 9. So this one was really complicated because not only did we not have a 0 on one side, but we have these starting factors that weren't factors that would work. The only way that the x minus 3 and x plus 18 would have worked for us is if the other side had been a 0 to start. But we need 0 first and then factors second. Okay, so let's look at some other examples to really illustrate the idea. Notice on this first row, the first problem, we're running into a similar issue as before. We have factors of x and 2x minus 7, but we don't have the 0 we need. So I need to move 39 over, but in order to do that, I need to distribute the left side to create terms. So I will distribute the x to get 2x squared minus 7x equals 39. And then I need to move my 39 over to get my 0. So I'll subtract 39. This is going to give me 2x squared minus 7x minus 39 equals 0. 39 did not collect as a like term, so it just moved over. Now notice what I have. I have a trinomial on the left, but it starts with a 2. It doesn't start with a 1, so I need to use group factoring. So I am going to say then that I will use 2 times negative 39 off to the side. This is negative 78. And then as you're running factor pairs, hopefully you'll run across the correct one. Negative 1 times 78, negative 2 times 39, negative 3 times 26, negative 4, no, negative 5, no, negative 6 goes in 13 times. And I think I'm good here, but I need 6 and negative 13 because that's the one that will add to negative 7 for us. Okay, so now I'm going to need to factor. So these are going to be factors here, but I'm going to use group factoring to do this. So I'm going to take my 2x squared, and then instead of negative 7x, I'm going to say plus 6x minus 13x minus 39. My goal here is to get that factored. So I've got a 2x and x plus 3, and then here I've got a minus 13 and x plus 3. This is telling me to use factors of x plus 3 and 2x minus 13. Not the easiest factors in the world. X plus 3 and 2x minus 13. Now I'm going to make smaller equations from those. X plus 3 equals 0, or 2x minus 13 is 0. And I'm going to solve. In this first case, it's pretty straightforward. X is negative 3. Or in this case, I have to add 13 and then divide by 2. 2x is 13, divide by 2, and x equals 13 halves. So these would be the solutions right here. I'll circle them. Okay, so that one had a tough factorization in it because it was a factoring by grouping problem, and then the numbers were large. Okay, so let me look at this next example here. Negative 7x squared plus 63 equals 0. Here's something I notice. I notice there's a 7 in common, and I also notice my first factor is negative, or my first term. I'm going to factor out a negative. Negative 7, and that'll give me x squared minus 9 equals 0. Remember from a previous lesson where we factored completely? X squared minus 9 factors, that's a difference of 2 squares. So I'm going to go ahead and break that into 2 factors. What do you square to get x squared? X. What do you square to get 9? 3. And then 1 minus 1 plus. Notice I have an additional factor of negative 7. When I go to create equations, I'm not going to set negative 7 equal to 0 because negative 7 can't equal 0. It's a non-zero value. It would not make sense to say negative 7 equals 0 because when I set the factors equal to 0, I'm looking for a number that makes them equal to 0. So I'm not going to use this negative 7 for this case. I'm only going to use the x minus 3 and the x plus 3. So this is going to give me x minus 3 equals 0 or x plus 3 equals 0. And if I add 3 to both sides, that gives me one solution as x equal to 3. Subtracting 3 gives me x equals negative 3. So these would be the 2 solutions right here. Sometimes students say, what happens with the negative 7? Well, mathematically, you actually could come along here and divide by negative 7. It's mathematically correct to do that. And that becomes a 1 and kind of becomes not a problem. And 0 divided by negative 7 is 0. So when you're creating your smaller equations with this zero factor theorem, you only use factors that have variables inside of them. So let's look at our next example. We've got a situation where we need a 0, so I'm going to take 15 off of both sides. This gives us 12x squared plus 57x minus 15 is 0. I see a 3 in common, so I'm going to factor it out. Now I'll get 4x squared, and then I'll get 19x, and then I'll get minus 5 is 0. So I do need to factor, and I'm looking at my trinomial, and it's kind of a big one because it starts with a 4. 4 times negative 5 is negative 20, and I'm looking for the pair that adds to 19. So that would actually be negative 1 and 20 itself as the pair. So I'm going to group factor. I'll take 4x squared minus 1x plus 20x minus 5. I'm factoring out that trinomial. That's going to give me x, 4x minus 1, 5, 4x minus 1, and then that gives me 4x minus 1 and x plus 5. So those are my factors that I will use. 4x minus 1 and x plus 5. I'm setting my variable factors equal to 0. And if I add 1 here, that gives me 4x equals 1, divide by 4. X is 1/4, and then take off 5 here, and x equals negative 5. So those would be the 2 solutions that go with this equation. And then in my last example here, 4y squared minus, or 8y equals, 8y equals 14y squared. I talked about making the y squared term positive. So in this case, what I would do is I would actually subtract off 8y because I want y squared to be positive. So this is 0, positive 14y squared minus 8y. I see a common factor of y. Oh, actually, I see a bigger common factor than that. I see a common factor of 2y. 2y, and this is going to give me 7y minus 4. So I'll say 2y equals 0 or 7y minus 4 equals 0. So, whoops, if I divide by 2, y is 0. Here I'm going to add 4, which gives me 7y equals 4 and y equals 4/7. And those would be the final solutions to that equation.